Hi scholars, let's look at TEK 4.3e. It says, I can represent and solve addition and subtraction of fractions with equal denominators using objects and pictorial models that build to the number line and properties of equations. So basically, there's going to be pictures and visuals and manipulatives and number line that show addition and subtraction. And all the denominators will be the same. So it's like 1/8 plus 1/8 plus 3/8 or something like that. Or 7/8 minus 2/8. So let's get started. So let's take a problem like this, 5/8 plus 2/8. Now, we know, if you've seen from my other videos, that you keep the denominator the same and you just add the top, the numerator, and so you know your answer is 7/8. But the question is, the pictures and the models that represent it, which picture and model represent 5/8 plus 2/8 equals 7/8? So here's one example. So right here, you can see that they use one whole to show you, 8/8. 8/8 is equivalent to one whole. And so here is my 5/8 right here, plus my 2/8. And then obviously that piece is going to be missing. I mean, if it was there, it would be 8/8. But obviously we're doing 5/8 plus 2/8. So the picture would look like this. And then they would do this to show you 5/8, and then this, which is 2/8. And so then you know to add those two together, and that equals 7/8. Now, if it was 8/8, then it would be like 5/8 plus 3/8 or something like that. So you know 8/8 minus 7/8 equals 1/8, and that's why there's a piece missing. So let's take a problem like this, 5/8 plus 2/8. Now, we know, if you've seen from my other videos, that you keep the denominator the same and you just add the top, the numerator, and so you know your answer is 7/8. But the question is, the pictures and the models that represent it, which picture and model represent 5/8 plus 2/8 equals 7/8? So here's one example. So right here, you can see that they use one whole to show you, 8/8. 8/8 is equivalent to one whole. And so here is my 5/8 right here, plus my 2/8. And then obviously that piece is going to be missing. I mean, if it was there, it would be 8/8. But obviously we're doing 5/8 plus 2/8. So the picture would look like this. And then they would do this to show you 5/8, and then this, which is 2/8. And so then you know to add those two together, and that equals 7/8. Now, if it was 8/8, then it would be like 5/8 plus 3/8 or something like that. So you know 8/8 minus 7/8 equals 1/8, and that's why there's a piece missing. Let's look at another example. 4/10 plus 5/10. So, without even looking at pictures, you know from my other video that I put up to just add the numerator and you keep the denominator the same. So, looking at models, we have 4/10 right here plus 5/10 here. And that explains why I have 9/10 all together. And you always have it like with a one whole above it, just so you can see that you almost have one whole. 9 out of 10 pieces, so you're just missing one piece. So if you look at it from another way, you can do that. Okay, let's look at one more example. 2/12 plus 3/12 plus 1/12. So here is what the picture would look like, or the models. So we have here 2/12 plus 3/12, and then 1/12. So when you put them together, you have 6/12. And so then your answer is like that. Which, by the way, is also equivalent to half. Okay, let's look at a subtraction example now. 8/10 minus 5/10. So what you have to do is you start off with your 8/10, and again, I just keep this here so you can see the visual model that we are less than one whole. So 8/10, and then you're taking away 5/10. Now, sometimes like on assignments or pictorial models, like an assignment or pictorial models, then you start off with 8/10 and like you're gonna see 5/10 crossed out actually. So I can't mark on these, so you're gonna see me put X's. 5/10 taken away. So then what's left over is 3/10. And so then that's your answer. 8/10 minus 5/10 equals 3/10. Here's kind of like a visual model where you could see the 5/10 crossed out, and then you are left with 3/10. Okay, let's look at another one. You have 7/12 of something, and you're taking away 5/12. How many 12ths do you have left? So, you know, obviously we know how to do this. You do 7 minus 5 is 2, and then obviously you keep the denominator the same. But we need to look at pictorial models. That's really the emphasis in this TEK. So you start off with 7/12, 1, 2, 3, 4, 5, 6, 7/12, and you're taking away 5/12, 1, 2, 3, 4, 5. So you can do that and be left with 2/12, but what I've seen from like assignments and things is that these are crossed out to show that this is a subtraction problem. So if you see like fractions and some things are crossed out, you can guarantee that it's a subtraction visual. So like let's look at this one here. This is 7/12 shaded in, and we're taking away 5/12 of those 7/12. So like I might do 1, 2, 3, 4, 5, like a complete X out of those 5/12. And I'm left with 2/12. Or look at this representation. Here's 7/12. I need to X out 5/12. So I might do this. And as you can see, there's 2/12 left. So sometimes you might be given the picture and you have to write down what the math problem is. You know, you might not get this and then you draw or pick the picture that represents it. You'll be given the picture and you have to write down what it could be. So we're going to practice that next. Okay, so let's look at this visual right here, and I want you to think about what is exactly going on. Brainstorm if this could be subtraction or addition. You don't need to pay attention to this. This is just there so you can see the comparison that obviously even with this and whatever's being done, it's less than one whole. So this is addition because we are showing this piece combined with this piece. So 3/5 plus 1/5. And then my answer is 4/5. I'm going to show you what this would look like on a number line, because on number lines you might see that too. So obviously this is less than one whole, so here's 0 and here's one whole, and then here's my fifths. So if I have 3/5 added with 1/5, that's what it looks like. In fact, this is exactly what that is. When you're going from here to here, I'm showing that that's 3/5, and then from here to here, I'm showing that's 1/5. And the reason I know that it's fifths is because of the spaces. In my other video where I talk about fractions and decimals on a number line, I emphasize that you need to count the number of spaces. So I want you to press pause and see what number sentence you can come up with that represents this visual. I also want you to draw a number line and another visual that is either in circle or rectangle format, but not like a straight rectangle, like, you know, multiple stacks in the rectangle. So in this one, we can tell that it's putting two pieces together. So 3/6 plus 2/6 equals 5/6 total. Okay, and two other ways to represent it. You can do a number line to show 0 and 1. So we have 3/6 right here plus 2/6 right here. And then as you can see, 1, 2, 3, 4, 5. Whoops, sorry. You can see that it jumped 5/6. And then another visual, you can cut this into sixths and do 3 in one color and then like, 2/6 the other way, I guess. 2/6 in another color. Okay, so looking at this visual, I want you to write down a number sentence that represents this and draw like this also like in a circle or a stacked rectangle. Press pause and press play when you're ready to check, and then I'm going to show you how to show this on a number line. Okay, so as you can see, my total to start off with is 9/10. And then I'm taking away 1, 2, 3, 4, 5, 6/10. That's going to leave me with 1, 2, 3/10. Okay, and now as for like another visual, you could do a circle, and you can cut that into fifths. So, cut it into fifths and then cut it into tenths. And then you can show 1, 2, 3, 4, 5, 6, 7, 8, 9, and then cross out 1, 2, 3, 4, 5, 6. Okay, and then a number line. So it's very similar to what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry that it's not evenly spaced. So we have 9/10 to begin with. So you might see this. And then to show the 6/10 taken away, you might see some kind of X like that. Now remember, you can't say 9/10 until you count the number of spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So of those 10/10, 9/10 is, covered, and then 6/10 is taken away, and then I have my 3/10 right here left over. Okay, draw another visual that represents this, write a number sentence, and show it on a timeline. Press pause, work the problem, press play when you're ready to check. Okay, so from what it looks like, we have 4/4 to start off with, and 1/4 is taken away, which means 3/4 is left. Okay. A visual for this could be, you could do a circle, and all of it is shaded in, and then like 1/4 is crossed out. Okay, and then a number line would be from here to here, and then we're starting with 4/4, and then 1/4 is taken away.